Hello to everyone, and welcome to the MSD Basic Steps webinar. First of all, I want to suggest you to download our latest MSD software from our website, so raresafety.com. In the download section area, under software section, you will find the latest MSD software. Okay, so today we will see how to do the first step into the MSD software, into the Mosaic Safety Designer, and we will see how to properly use the software in order to make the safety project in an easy way. First of all, we can see that we have the new project button. So let's click the new project, and then we can insert some information about the project. Every information, everything that we are going to do into the software will be printed into the report. So company rare, user Giuseppe, and then we can say webinar MSD. The first big news about the software, about the new version of the software, is the multi-page selection. So now it's possible to enable the multi-page selection in order to build your software in an easy way. Now, the first window is the hardware configuration. So here you will insert your module, your hardware, what you are going to use in order to manage all the safety function of the software, of the machine, sorry. So we have the M1, as we already know from the previous webinar, the M1S, and the M1S COM. Today, we are going to use the M1S COM because I want to introduce you and want to remind you that the next webinar will be directly focused on the M1S COM functions, the PLC, and the field bus communication, and the remote control from the Ethernet port. So M1S COM plus all the expansion that we already know from the Mosaic family. In our example, we have one MI804. And as you can see here, we have all the information about the input and outputs that we can use inside our configuration. So also, if you use the offline, the software in offline mode, you can build your hardware configuration and already put the module in order to know how many inputs and output you can manage. You can choose between the dynamic input order on the field bus, but we will see this in the next webinar. You can also choose to configure the module firmware version. In this case, if you have a particular version that is able to manage particular function of the MSD software, you can choose, you can select and says, okay, now you can use only the 0.3 version of the MI804. In this case, all the functionalities will be kept only with the 0.3 version. If not, we will consider only the last version. So let's click OK. And we are going to build the project that the example that we saw during the previous MSD. So one safety light curtain, one emergency stop, one RFID, and a type 2 photo cell. Then we will make a very simple logic, and we will manage 4 OSSD output and see the difference between the properties of the OSSD output and how we can manage particular and specific function for every OSSD just by clicking on some check on the menu. So page navigation, this is the first stuff. Now we have, as I said, now we have the pages. So page 1, 2, 3, 4, we can use up to 255 pages. We can delete because we want to do in the right way. So now it's time to choose how you want to organize the software. So are you going to use the pages in order to organize them like inputs, logic, outputs? Okay, just rename the page and I can show you how to use the pages and the interpage function in order to communicate the signal between the pages. Or you can use page one, for example, for the main unit, page two, three, and four, and so on for all the expansions. And then use one at the end, one page in order to collect all the logic and drive the output. Today, the example, the very simple example, but is the best way to understand how to use this tool. We are going to do like input, a logic, and outputs. So my first page will be input. Second page, we can right click and rename the page as logic. Then we can also rename the page and say output. Okay, so now here we can use it like a sort of table of variable because we can insert the light curtain here, the emergency stop, the RFID, and a type 2 photocell. All the Windows command work. So we can do the Control C, Control V for copy and paste. So now you know that this is our hardware. So what we are going to manage inside our software, we are going to manage one light curtain. I suggest you to insert the item description for every single block, because in this way, when you will print the report, you will see the exact description of every single block in the electrical diagram and in the field bus communication exchange mapping. So as you can see, we don't need to open any new tab, new window, just to in order to change the behavior of the block. Every single block is a certified block, of course, and every single block allow you to um, reach the highest category level. Light curtain. So here is our emergency stop. This is our RFID, and this is our type 2 photocell. Okay. As you can see, for the emergency stop, if we have to manage, for example, the short circuit control, we need to test. We need to test the electromechanical contacts of an emergency stop. And if you remember from the last training, from the last webinar, we said that every single module, main unit or expansion with inputs has the output tests that are used especially for this purpose. So we don't need to use any OSSD output and change the behavior. We just select the output tests already present on the module. Another new feature of the new MSD is to select the labels and to is um, and do the automatic input assignment. So now we will use all these module, all these function block, all these device, and we will connect to the M1S COM. And as you can see here, we already have all the information. So another suggestion from the software point of view, for the software engineer that maybe already knows something about the electrical cabinet, but if we are very focused on the software, we already know where the light curtains will be connected. So input 1 of the M1SCOM on pin 17, input 2 of the M1SCOM on pin 18, and then I can also assign the OSSD 1, OSSD 2. So OSSD 1 of the light curtains will be connected to pin 17. OSSD 2 of the light curtain will be connected to pin 18. And I can do this on every single function block. So here we already have the electrical diagram. So now, based on the fact that these are our input page, but we need this input page for other purpose. So for the logic, for example, we will use what we call the interpage. So I will use one here, one for the emergency stop, one for the RFID, and another one for the type 2 photocell. Then I connect all these function block to the right interpage. The interpage is a particular operator that allow you to use the same signal from the main function block to any other pages for any other purpose. So this is our curtain. This is the emergency stop. This is the RFID, and this is the type 2 photocell. Let me move it here. So just to see what is possible to do as operator and as logic, we have simple logic here with simple Boolean logic. So OR, XOR, AND, NOR, XNOR, NAND, NOT, the multiplexer, the logical macro, the comparators. We have memories with the flip-flops. We have the user restart manual in order to manage or better, in order to save the reset signal. Safety guard lock, especially used for the reset command of a interlock switch for doors, counters, timers. Also, the muting function is possible to uh, be managed by the Mosaic. So based on what kind of muting, monodirectional, bidirectional, 2 sensors, 4 sensors, override function. We can also use standard light curtains without the integrated function and use the muting function from the software, from the Mosaic, in order to manage the muting function. Then analog operators, if we use the analog module, so the comparator, math, equality check, or speed comparator if you use the speed module. And from the items, so the items is the hardware that we are going to manage, that we will manage with a Mosaic. So light curtains, solid state devices, 2 hands control, e-gate, single e-gate, the lock feedback, so the contact from the coil of an interlock switch for doors, the network, the mod selection, the photocell, the emergency stop and enable, the foot switch, the safety mat, or the same block can be used also for edges. The standard sensor, as you can see, the main difference between a certified block for the safety block for the decertified in order to manage the safety signal, and a non-safety block is the color, mainly. The switch, the enable grip switch, a generic testable safety device, the RFID, the restart input, the field bus input that we will use in the next training, in the next webinar, when we will go deep into the M1S COM function, the always false and always true. Then speed control, standstill and speed, only speed over speed, window speed control, speed equality check. The analog input, and of course also the output based on the hardware that we have in our configuration. So this is the main overview of what we are going to manage with the Mosaic based on your application. So we already have our hardware. So now we assign the inputs, but the main stuff is to check the property of every single block. So for example, I can use the manual reset for this block. So the output will be on in on state only if you connect a reset signal on the emergency stop function block. Then the output test. I can use, for example, test 1 and test 2. This means that pin 13 must close to pin 19 by passing to the emergency stop. Pin 14 must close to pin 20. If we do a mistake, every single mistake in our system, in our project, is already diagnosticated by the module. And you can see it from the LED, from the LED, and from the monitor function. Same stuff for the type 2 photocell. Every type 2 photocells must be tested in order to be certified as a type 2 photocell. And we already have the proper function already in the block. So pin 15 must enter into the emitter, and from the receiver, the signal must go into pin 23. Logic. So how can we use those signals into the logic? We will use the interpage in. So for example, this is our emergency stop. And as you can see now, we have the signal from the emergency stop from page that is called input. And we can also add light curtain, and the RFID, and the type 2 photocell. So now let's imagine to use a very simple, project. So we will do like the AND port, so click, drag and drop. This is the main functionalities. So you choose, click, drag and drop into the project. And now we have 3 inputs, the RFID and the type 2 photocell. And the result of this is in series, maybe with the emergency stop. Can move this, and we can use the same philosophy if we have a bigger project, of course. And what we can do also is to collect the result of this logic, of this function, and use it like interpage out. And let me say, I don't know, maybe safety, okay. Okay, so the result of this logic is safety, okay. So with the safety, okay, we will drive 4 different outputs. So we will use the safety OK here. As you can see, we already assigned the interpage, so we can use it like some variables, okay, that we can use in our project. Just remember to use the interpage in and out. Little discussion about this part of the operators. Serial output. In the past, we didn't use the field bus communication in order to transmit the signal status from the Mosaic to a PLC. In the past, we used the serial output. So we collect all the signal into the serial block, okay? We can use also more than one serial output block. You need to select the mode selection, okay, with the bit duration and the intercharacter duration, and then you will use one output to be in order to be connected to the PLC input, and then analyze the serial signal based on this timing. Of course, this functionality is always present if you don't use the field bus communication, or if you don't need to use the field bus communication. But during the next webinar, we will see what our field bus communication is able to do in order to do the right diagnostic and to exchange data. But just to explain this to you. The network function is the function that allow you to do a local network between main units, and you can manage the stop and the reset of the plant, of the machinery, based on the status of every single main unit. Reset is like a reboot of the system. So in case of some diagnostic where you are where you need to check what is happening and reset the power supply, you don't need to reset the power supply directly on the pins, but you can use this reset. You can use it like a reboot signal. OSSD EDM is for the external feedback monitoring from another input. And you can also use different feedback signal in order to drive one single output. The terminator is used when you have this kind of situation. So let's imagine to have this project, but now I don't need the light curtain. So I will remove this. So I don't need to change the wiring. I don't need to change anything. Just download the new software with the terminator, and we will not consider pin 17 and 18 signal. So let's go back here. Now we have to manage the output. So we know that with M1S, M1S, M804, we have 4 OSSD output. We can use like as a single channel or double channel output. Okay, and let's see this little overview of the properties. So the manual reset here. So if we need to manually reset the OSSD output, we don't need to do anything extra. We have specific pins that are used for this purpose. So we will use 4 different output. I can assign them here, or I can also use this function. Okay, and again, we already have the electrical diagram. So OSSD1 of the M1SCOM on pin 5. OSSD2 of the M1SCOM on pin 6, and so on. So now we will see different behaviors based on the properties. So what you can do just by doing a single click. So this is our automatic reset without status, without any feedback control, without anything. The second one will be the one with the feedback control. So if we connect the OSSD to a contactor, to a safety relay, and we need to check the feedback, we don't need to add any extra block. Of course, we have the OSSD EDM, but it is used for a special purpose. As a standard, is just a check on the external K-time monitoring, and then you are going to connect the feedback contact or the series of the feedback contact on pin 8. And that's it. So if you want to do the feedback control, you don't need to use any extra input. You don't need to use any extra function block. Just check external K-time monitoring and connect the feedback to pin number 8. So now we will see also two examples of the manual reset. Same philosophy. We don't need to use any extra input, any extra function block. Manual reset. And then we can choose the reset position, for example. This will be our reset 1, and you will connect the pin. On pin 7, you will connect the reset button. Same stuff. Sorry. Now we use the feedback 4, and you will connect the feedback, the reset button on pin 12. And also, the logic for the reset is different. We have the manual one, like the OSSD number 3, or we can also use the monitored. So as you can see here, the manual one is the one that is on when you press the reset button. The monitor function is the reset that allow the OSSD output to turn on only if you press and release within a certain time, that is 5 seconds. So based on our logic, that is safety okay, we can do this. So for those of you that already use the Mosaic software, the MSD software, without the interpage, without the pages, this can be not difficult, but graphically not good to see. In this case, it would be also good, it would be also better to do the diagnostic. So once we've done, we can do the validation, because the validation is already integrated, and we will see the CRC code. We already spoke about the CRC code in the last webinar. It's a unique code related to this specific configuration. If I change 5 milliseconds, if I change 1 millisecond on every single function, if I change one check, also the CRC code is different. And we will see how to analyze this data during the next webinar with M1SCOM, because we can also check the CRC code every time at any time from the PLC if you have the field bus connection. The amount of input that we use, the amount of function block, the amount of SSD, and status output. So let's click OK. The validation is OK. This means that it's not OK, this is a safety project in category 4. This is OK. So we connected everything. Nothing is empty. We can download it, so you need to test. But before testing directly on the module, we can also do the schematic simulation. So as you can see, every block that used the time like this because we use the external k-time monitoring, needs to start the cycle. In this case, we simulate the cycle time of the module. So every signal that is red is off, the signal that is green is on, and when we have the dashed line, we have a diagnostic. And the diagnostic is always reported on the LAD, it's reported on the software, and we will see this is also reported on the FIBUS. So light curtain is on, RFID is on, and type 2 photocell is on. So everything is already replicated with the direct interpage. But safety is not okay because we press the emergency stop. So now we release the emergency stop. And as you can see, output 1 is on, it's green here. OSSD number 2 is on because the feedback signal is okay. But we have two dashed lines. Okay, so when you have this kind of situation where the output is not on, we have some external failure, we have some diagnostic, something is blinking on the module, you can go in monitor, check the situation, and if you have these dashed lines like this, you can put your mouse on the dashed line and see waiting for reset. This is the same view of the monitor, waiting for restart. So we know that this one is the output with the manual. So at the same moment, when I click the reset button, the output is on, and I can keep it pressed and stuff like that. With the OSSD number 4, we have the monitor. So this means that if I keep it pressed, the output, or if I press, the output is not on. We have to press and release the reset button within 5 seconds. 5 seconds passed. So now I need to repeat the reset procedure. And as you can see, I don't need any extra function block. Everything is inside the properties of a property of every single OSSD. So now let's simulate, for example, a feedback error. The feedback error is the most common error when we have the the feedback control with the Mosaic. So let's imagine that the time is not enough in order to check the feedback signal. So press the emergency stop. As you can see, everything is off, but we have this kind of diagnostic. The feedback is not congruent with the command state. This means that we have to check something on the feedback. And in order to do this, you need to stop everything, check what is happening, solve it, and reset. So now we will also return in the OK condition. So we solve it from the wiring, light curtain, emergency stop, RFID, type 2 photocell, reset, reset. Okay, so this is a simple logic. This is a simple software, but we can use the same philosophy also to a bigger project just by using the tool, the software in the right way. So please use the interpage, check what you really need, what you are going to manage into the software, and then you have all the functions already integrated inside the software. Last stuff is the allocated resource. So in order to know how many input and output left you have or you can use, You can check this by clicking on this icon. So just to see the allocated resource. And the main stuff, at the end of everything, you simulated, you tested, you did everything. So now print the report. I show you again this because this is very important. Print the report. So click, you can choose the format. I will use the HTML. And this is the project report. So the webinar MSD made by me from company Rare on this date, this is very important, with this CRC code has this Mosaic configuration. The module, the master, cycle time, safety information. So we cannot say, oh, you are in category 4. We can also suggest what you can do in order to be in category 4. Okay, we did everything. But we don't know if you use a well-tested component, a well-proven component, a certified component. We don't know. So but we can provide the information. So if you did everything okay, you can use the safety information in order to do the risk evaluation and says, okay, what is your performance level according to the ISO 13498, 13849, sorry. Same resource, use it, and electrical diagram. So guys, if you remember at the beginning, I suggest you to use the light curtain, the emergency stop, the RFID, and then type 2 photo set. So to use the item description, because in this way, if you are not the software engineer, if you need, if the machine is stopped, if you need to check what is happening, at least you can ask for the report and you can check the connection. So I know that light curtains connection is on terminal 17 and 18. Function block has the test on 13, 14, and the input on 19, 20. RFID used the terminal 21, 22. The photocell used the 23 and 15 as a test. And the same for the output, for the test, and for the dependence of input. So output 3 depends on the inputs number 3. So the input number 3 is the RFID block. So we have all the information already printed inside our report. And then we have all the information. I will scroll because this is the matter of the next training, the M1SCOM in this case, but also every field bus expansion. I already have all the information about the status of every single input and output function block. So we have the Mosaic status, the M1SCOM input, the MI804 inputs, all the possibilities with the expansion for the inputs, the restart, the feedback of the field bus. We will explain this very deeply during the M1SCOM training, and the diagnostic directly from input, output, CRC code, and internal failures. At the end, you have to sign. There is the signature. And the signature means that someone is in charge of this, is responsible for everything about the software. Of course, software, hardware, we need to check. But at least for the safety project, for the risk evaluation, we need to sign the report. And the report is for the machine manufacturer. Is the technical document that must be attached to the technical documentation of the machine. So please remember this. As Rare, we don't want just to sell products and says, okay, this is the code, this is the price, and stop. We want to be partners. So if we can suggest something to you, we will do it. And that's it, guys. I hope you enjoyed the first step into the MSD software